In this tutorial, we'll look at accumulation algorithms using arrays. What I have is a class called practice, and I have a main method. And in my main method, I have an integer array called numbers. And I'm going to try to find the sum of all the values in the array. So I've written the header for a method called sum. It takes in an integer array and returns the sum of all the elements in that array. So I'm first going to create a variable to hold the sum, and this is what I'm going to return. In the middle here, I have to iterate through the entire array and grab all the elements and sum them together. So this is going to require a loop. You can write a traditional loop, a regular for loop for this, but I'm going to use a for each loop because it's really clean and easy to read, and I'm only reading the values. I'm not trying to modify the array. So this for each loop will iterate through the array, and as I visit each element, I will accumulate a sum. So let's test it by calling our method sum and passing in our array numbers. And 1 plus 2 plus 3 plus 4 is indeed equal to 10. Let's add an average method. This time, instead of returning an int, I want to return a double. So this is going to take an array. Now, because I already have a sum method, I'm going to just call the sum method and get the sum of all the values in the array. And I know how many values are in the array because I know the length of the array. So the average is simply going to be sum of all the values in the array times divided by the number of all the values in the array. So that's going to be numbers.length. Now I'm storing the average in a double, but I have to be careful because this is integer division. I don't want integer division. If I run this right now, I'm possibly going to get the wrong answer. We'll call average. So I get 2.0. That may not be the actual answer. So be careful about that. You'll want to cast one of the values to a double so that you get real division. So our answer is 2.5, which is the true average for this array. Now let's look at an accumulation for a product. So I'm going to delete this method, and we're going to create a method called product. And public static int product. And we'll take in our array. Let's call it numbers. All right, so I need a variable for the product. And remember, when you're creating a product, you want to initialize product to 1. That's the identity property of multiplication. And so you'd want to start it at 1. If you started it at 0, then your product would end up at 0. So again, I'm going to use a for each loop because I don't want to modify the array. I'm just going to read all the values from the array. So this is just product times equal each of the elements in the array. So when I run this, it'll print out 24, which is the product of 1 times 2 times 3 times 4. Another form of accumulation is to count. So I have a string array called animals with snail, hen, rabbit, and bear. And I'm going to call this method and print out how many animals contain the letter A. So let's write this up. So I have to have a variable for count, and that's what I'm going to return at the end. And in the middle, we have to accumulate our count. So I can iterate through words and then evaluate each word as I do so. So we'll create a for each loop. And in here, I'm going to test to see if the word contains the letter. Now, I'm going to use index of because that's part of the AP subset. That's a method that you have to know on strings. So word.index of, and we're going to pass in the letter. And this returns an integer, which is the index of that letter. And if it's not present, it'll return a -1. So if it is present, it won't be -1. So if it's found, its value will be not -1, or we could think of it as greater than 0, greater than or equal to 0. That means that it has a valid index. If that's the case, that means the letter is present and I want to count it. So we'll say count plus plus. And I've returned count at the end. Let's run this code. Snail, rabbit, and bear each have a letter A in it. So we should see that we have 3 animals with the letter A. So what you've seen in this tutorial is multiple ways to use algorithms that have accumulation.